we're going to show you the headset that I'm about to put on. So here we have a Galea Alpha prototype. You can see in there, we've got the face interface with the PPG currently emitting the light from the LEDs, and then all the other sensors in the face that we can talk through in a minute. And then in the back here, we have the 8 active electrodes on the harness that goes onto the head. So without further ado, I'm going to put this on. We'll go out and around. Going in.
Okay.
Got the ear clips.
Okay, so in this session, we're gonna walk you through how to use Galea with the GUI. So I'm gonna start sharing my screen to show you guys the OpenBCI GUI. Okay, let me just use the mouse.
All right.
Can you see my screen, Joe?
Yep, coming through.
Okay, great.
And
So
it's a little choppy because of the Zoom screen sharing, but we'll, you know, yeah, it's really anyone who's screen shared video over Zoom, you know, the aliasing of this is much smoother in the actual programs, which you can see on YouTube. We have a couple other videos of the data in action. All right.
great, thank you, Joe. So yeah, it's a little choppy because of the Zoom transmission, but you should be able to see the different widgets with the data coming in. So when you open the OpenBCI GUI, the first thing that you see are 3 widgets: the time series widget on the left, the signal quality widget on the top right, and the Galea auxiliary data widget on the bottom right. So the first thing we usually do is check the quality of the signal using the signal quality widget. On there, if you switch from live to impedance mode, you can run an impedance test across the channels to check how good the connection is on your face. So the widget will automatically loop through every individual channel and give you a value, which is represented by a color. So green means that the impedance is really low, which is what we want. Yellow is okay, and red is that the impedance is high. So you're gonna wanna adjust the headset a little bit until it goes either green or yellow for most channels.
So you can see that some of the channels, especially on the bottom here on my face, are red. So we're gonna loop through them again, and hopefully they're green next time around.
Yeah. Yeah, that's getting better. So Conor moved it a little bit, and now the cheeks are looking better. Let's see what channel 5 says. Green.
All right.
Okay, that's good.
We're in good shape.
So now that we know that the headset is making good contact, we can show you some of the data that's coming from the headset. So let's start with the auxiliary data. The auxiliary widget shows Conor's heart rate. So right now it's looking really good. It's getting the heart rate from his forehead. And you can see it in the first 2 lines.
Yeah, so at each of these peaks, these kind of the peaks of these, that's my heart beating. Occasionally, especially when I'm a little nervous, I get a little bit of a murmur here. You can actually see sometimes my heart will kind of skip a beat.
Also, for those of you that are wondering, Conor right now is seeing the GUI inside VR. That's how he can like point at the stuff and show you.
Mm-hmm.
And I'm seeing it on the monitor. So under the heart rate, you can see the EDA. That's electrodermal activity, and it measures the conductance of his skin. So if he sweats a little bit or gets nervous, it'll go up. And the way that we usually test this is by like Conor pinching himself on the arm.
Yep. And right now it's actually doing exactly what we want it to do, because since we're doing a live demo, I'm definitely a little bit more aware of the fact that I'm presenting in front of people on the internet. And you can see that ever since putting the headset on, my EVA has been just gradually climbing up. And it's because of this kind of, minor anxiety of just, knowing that I'm presenting to people. So if you ever, walk into a room full of people that you're meeting for the first time, or you get up on stage and you give a presentation and you notice that your brow starts to sweat, that's really what we're looking for here. So in theory, over time, as I start to relax and as we get further into the talk, this would kind of plateau, and then you would see more typical kind of rises and falls with that correspond to shifts in my, kind of alertness or anxiety.
Yeah, it looks like it's still going up, but we will probably see it stabilize over the next few minutes.
Yep. I mean, I
It's
can
getting
actually
better.
feel it. Like I can feel the sweat on my brow. So. Cool.
Okay, cool. So maybe we can test the pinching later once it's stable.
Mhm.
So on the left, you can see the raw data. Well, actually, it's filtered. We can talk more about the filters that we're applying automatically later. But you can see the data coming from the 16 channels. So channels 1 through 4 are EMG. Those are located above and below his eyes. You can see that in the signal quality widget. Channels 5 and 6 are EOG. So that's electrocoulography. It's the electrical activity coming from his eyes. And one of the channels is a vertical EOG located above and below his left eye. And another one is the horizontal EOG. That's channel 6 located across his face. Channels 7 and 8 are passive EEG, which are on his forehead. And channels 9 through 16 are active EEG, which are distributed along the midline of the head and the back. So maybe you can turn your head around a little bit so they can see. So the active electrodes are located here and then along the midline. Great. So I think first we can start showing them the EMG data. So if you can just leave the EMG channels and open the EMG widget. So in the time series widget, we have a few buttons at the top where you can select just EMG, EOG, EEG for convenience, but you can also select individual channels that you want to see, or maybe like turn on or off if needed. So Conor just opened the EMG widget on the top right. And what this widget does is it gives you a normalized version of the data. And it offers several parameters that you can change, like, for example, the window that you are smoothing the data over, or the limits that you want to see set for your 0 and 1. So right now we have 200 as the max UV limit and 20 as the minimum. So let's show them some smirks. So channel 1 is Conor's left cheek and channel 2 is his right cheek. So if you smirk left and then right, we will be able to see the spikes both in the time series and in the EMG widget. So you can see he's doing right, left, right, and you can clearly see the spikes in both widgets. And channel 3 and 4 are on top of his eyebrows. So you can also move each, Conor has been practicing, he can move each eyebrow individually to trigger them. So can you try like 3, 4, 3, 4? And it's the same as 1 and 2. You can see it when he's doing the movement. So with this, we usually like to play a mini game where I tell him which channel to trigger, and he will only move that muscle. So you can see he doesn't have a controller, so there's no way to cheat. And I'm gonna say the channel number and you have to make the movement.
All right, ready when you are.
Okay, so 1, 4, 2, 3, 4. Yeah, 1, 3, 2, 4.
Shoot.
Oh, that one.
This is the one I'm the worst at. Relative.
The right
I have a
eyebrow.
hard time doing the right eyebrow without the left eyebrow, and it's easier the other way around. There it is.
So it takes a little practice, but you can see that he's able to trigger the individual channels to go to the max value.
See, now I've got it left, right, left, right, left, right.
So Eva, say again, this is what? This is the face muscles being picked up by what sensors?
So this is a facial muscle activity being picked up by the EMG electrodes. So if we open the signal quality widget, the channels are located channel 1 on his left cheek, channel 2 on his right cheek, channel 3 on top of his left eyebrow, and channel 4 on top of his right eyebrow. And what he's doing is small movements to only move that muscle group, which we see reflected on the GUI.
So let's do that
So
one more
let's
time, just so everyone can see.
So let's do 1, 3, 2, 4, 1, 2, 4, 2, 3, 1. So you can clearly see how the channel that I tell him goes up to the max in the EMG widget, and the other ones remain at a low value because he's only moving that muscle group. You did well.
Thank you. Yeah, I think that was one of my better performances.
So another thing that you can see with EMG is jaw clenches. So if you clench your jaw.
I'm actually going to turn all this channels on because you
Yeah.
can really see this through the whole head. So I'm going to do some jaw grits and I'll emulate it with my hand.
So you can clearly see, you can see it in the EMG channels, but also throughout the whole headset, like Conor mentioned, because the impulse just propagates towards the back.
This is pretty cool too. I want to show you guys if I grip my jaw and I slide my kind of like lean my jaw to the left or lean my jaw to the right, you can see the data changing in the headset and you can see the difference between kind of left and right. So I'm going to use my hand to indicate.
It's
Now,
pretty.
yeah, in the time series, it's harder to see it, but if you're looking at the bar graphs and the circle graphs in the EMG widget, you can tell there's a distinct difference in the bars that rise and fall when I lean left versus right.
Yeah.
So if you were to classify that information, you could pretty easily decode a left jaw versus a right jaw.
Yeah, it's hard to tell in the time series, but it's visible in the EMG widget. So now I want to show you guys EOG before we move on to EEG.
Cool. Yeah, let's do that.
So for that,
Actually, there was one good question that came in. I just wanted to, stop for was a question about like, is the headset plugged in just for the VR or for the data transmission as well? So while you answer that, maybe you can also just talk like, what headset are we using currently? What headset will the beta use? Talk a little bit about the wired and wireless transmission and what headsets involved.
Yeah, that's a good question. So currently the cables are plugged in only for the VR headset, and the device that Conor is wearing uses the Valve Index. And Galea has its own battery and it works with Wi-Fi. So it's connected to our computer via Wi-Fi and it sends the data wirelessly. Our beta units will be integrated with the Varjo Aero headset.
Cool, thank you.
And also, I forgot to mention earlier, in the auxiliary widget, you can check the battery of the device. So that'll be the battery of Galea itself. So, okay, if there aren't any more questions regarding EMG, we can move on to EOG. So Conor just opened the EOG channels 5 and 6. Like I mentioned earlier, 5 is vertical EOG and 6 is horizontal EOG. To see EOG better, I'm going to turn off the filters in all the channels. So right now we are using some filters that we apply automatically to the data, such as, for example, a notch filter. Let me move this here for 50 and 60 Hertz. And a bandpass filter from 5 to 50. So I'm gonna turn these off. Great.
Yep.
And then I'll just open F50. So the reason we apply the notch filter to 60 and 50 is to get rid of the interference from mains, which in the US is 60 Hertz and in Europe is 50. think. So, okay, so we can see channel 5 and 6. Can you look up, down, up, down? So Conor right now is doing up, down, and we can see this movement reflected in the vertical EOG channel, a little bit also on the horizontal, but the one you want to be looking at right now is channel 5. So it's very clear. And if you do left, right with your eyes, we'll be able to see that in channel 6. So it's very easy to tell where he's looking. And let's do a combo. So can you look like upper right, lower left, upper right, lower left? And for those movements, we were able to see them in both channels. And now can you do the opposite? So lower right, upper left, lower right, upper left. Yeah, that looks good.
You can tell with one of them, they're following the same trend, and the other one, it's inverse, right? And that's how you can tell that it's working the way that it's supposed to. So if I go upper right, lower left, upper right, lower left, you can see that the peaks of the wave are actually inverse of each other. Whereas if I do the opposite, you can see that those waves are going in the same direction. I'll do it again. There you go.
Yeah, that's one. Great. Okay, I'm gonna turn the filters back on because we want them on for EEG. So our GUI gives you the option, by the way, to choose different types of filters, and you can choose different values for the bandpass, depending on how you want to process your data. These are just the ones we apply by default. So now can you open the EEG channels?
Yep, can do that.
And also I think the band power widget. So right now,
I'm gonna open this, which might slow the GUI down for just a second.
we still have the time series widget, which right now is showing only EEG data. And Conor just opened the band power widget on the bottom, which gives you an idea of the different band powers and so it gives you an idea of how strong the power is at different band powers. And on the top right, we can see the FFT widget. So that's the fast Fourier transform, which shows you the frequency spectrum of the data. So, okay, let's first show some blinks. So channels 7 and 8 are passive EEG. Like I mentioned earlier, they're on the forehead. And right now, Conor is doing blinks in sets of 5, I think. So you can clearly see them. These are the channels that we usually use to visualize blinks, but you can also see them propagate to like 9, 10, because those are just at the beginning of the midline. So they're pretty close to where he's doing the muscle movement. Yeah, they look pretty good. Okay. And so to show a little bit of the EEG data, we're gonna do an alpha test. So for this test, Conor is going to first have his eyes open, and then we won't be able to see any predominant alpha. And then he's gonna close his eyes, which will increase the alpha amplitude. Alpha is the frequency band that goes from 8 to 13 hertz. Depending on the person, it'll peak at a value between those. For Conor, it's usually like 11. And it usually peaks when you close your eyes or when you relax. So right now, actually, you can see, I can tell that his eyes are closed and he's relaxing because you can see a very strong peak at 11 hertz. You can see that in the FFT widget, and also you can see the alpha power band going above the other ones in the band power widget. And if you look at the time series and you count the waves, you'll be able to tell that it's around 11 hertz. So you're making some nice alpha. So now can you open your eyes? And we should be able to see the alpha disappear. So now I can tell that his eyes are open because I don't see the alpha peak anymore. Let's set it to 10.
Yeah, I just
And-
switched the FFT graph from a logarithmic on the Y scale to linear. So you can see the peak a bit stronger against the noise if I do it again.
Let's try it again. So as he starts to relax, we can see alpha coming up again. There we go. So you can see it's going up more or less until 5 UV.
I opened my eyes.
Yeah.
So now I'm back.
So now he opened his eyes and we don't see the peak anymore. The FFT widget also gives you an idea of the noise floor. So right now all our channels are below 2, which is what we want.
Really, like, most of the
Or below
floor
1.
is around 1 or even under 1.
Yeah.
Most of this is actually signal in the noise, even if it's movement artifacts. So everything that you see here in the kind of like theta, alpha, beta, gamma range is actually either movement artifacts or real brain activity. And if I really stop moving and stop talking, you'll see everything kind of start to settle to the noise floor.
Yeah, so you want it to be around 1 or lower. And, if you start to see high noise floor, you can always go back to the signal quality widget and check if any of the channels have started to make bad contact and use the widget to fix the headset on your head.
We had another good question actually that's worth pausing for. Someone joined late and asked, are the channels dry, active electrodes, passive gel, or saline electrodes? The
So
EEG channels, yeah.
So for EEG, we have dry active EEG channels. So the 8 active EEG channels are dry. They're an electrode that we designed in-house and they're flexible. And the passive EEG electrodes are also dry. And we use the same ones for the EMG and EOG channels on the facepad. Maybe after you take the headset off, we can show them the facepad again.
But that's a great question. And, we're really trying to optimize for the setup time and really make the setup as easy as possible. For those of you who are here from the start of the call, you could see that I started with the headset off my head and I put it on. And obviously I've worked with this headset now for a while. So I know a bit more than your novice in terms of how to adjust it. But, it took us less than a minute to get the headset connected with all 16 channels of EXG and the auxiliary data. And that's really the goal, is to really expedite the setup time.
It also works well with long hair. Like I wear Galea a lot and it works fine with my hair. I have pretty long hair.
Great. Well, if we don't have any more questions, should we stream some data out of the GUI?
Yeah, let's quickly show the packet loss widget.
Oh yeah, let's do that.
So we have a bunch of other widgets. This one is a useful one. It's a packet loss, and it gives you some stats on whether you've lost any packages since you started streaming, any packets of data. So we can see that we've lost 0, which is great. And we've been streaming data for like 25 minutes.
That's awesome. No packets lost.
Yeah.
25 minutes.
So that's great. And we have, can you open the dropdown? So we also have a spectrogram widget.
This is actually a good one to show alpha from a different view.
Yeah.
If I do notice here, I think the top is the left hemisphere and the bottom is the right hemisphere. So I'm going to go for alpha again and try and get, actually, let me set the max frequency to 20. And this will kind of cap out at beta. But now you should be able to see alpha more clearly if I close my eyes. So let's go for it.
I think it might be helpful to remove the face channels.
Now I've opened my
But-
eyes.
You can
This is
see,
super clear.
yeah,
And actually, my alpha on the left hemisphere seems much stronger on the right at the moment, which is kind of cool, but also maybe a little scary.
yeah. Let's see which channels are in.
Uh,
You can see that it got much stronger in the alpha power band.
Oh, I see. No, the problem is
Oh.
that's why.
Yeah.
Whew, okay, cool. I thought I was gonna have a little alpha asymmetry there. So let's just do the top channel, or the top bar. Ignore this down here, unless actually I could just let's go left and right.
And we're only using the active ones for this at the moment.
All right, so now we got left hemisphere on the top. Oh wait, no, that's not entirely true because 9, 10, 11, 12 are midline. So here, we'll keep these midline. Actually, let's just get rid of the midline. We'll go left and right. So now we've only got, channels 13 and 14, which are P3 and P4 roughly, and then 15 and 16, which are O1 and O2 roughly. And so let's see if I can get some alpha now.
Yeah. That looks pretty good.
Great, and now I've opened my eyes and you'll see that,
Seems equal for both hemispheres.
cool, that's good. Glad to hear that. Great, and there you go, there's our spectrogram.
Okay. I think those are the most important widgets. We have the focus widget as well,
Yeah, let's get that for now.
but let's open the networking widget and the EMG widget. So we've been developing a few games that you can play with Galea. And for those games, what we do is we stream the data out of the GUI using the networking widget. So the networking widget is the one on the bottom right, and you can choose different protocols to send the data out with. So we have UDP, LSL, OSC, and serial, if I'm not wrong. Yeah. Right now, we're going to be using UDP. So you can select up to 3 streams and say which data you want to send out. Conor just selected EMG. And if you can start the UDP stream, I'm gonna launch the game and move it to the screen that I'm sharing.
All right.
Let's see. Whoa.
Tricky.
So right now what you're seeing is what Conor is seeing inside VR, which is my desktop at the moment, while I'm launching the game.
Trippy.
Trippy.
Imagine how I
The
feel.
metaverse.
Yeah, we found it. We finally found the metaverse. This is what everyone's been talking about, guys.
It's been here all along.
Minute.
I'm waiting. I'm gonna close the filters window.
Whoa. All right, I'm gonna stop that now.
Eva, maybe you could pull up the GUI again and show where like an LSL stream or some of the LSL capability that's built in.
Okay, can you see? You guys can see my GUI, right?
Yeah, we see the Galea software again.
Okay, so
Might be best to show this after we do the UDP stream. Just I don't want to derail anything in networking.
Oh, right. Yeah, we're using it right now. We'll get to the questions about LSL after
yeah,
the
Yeah,
because we're using the part of the software we're using right now, the networking widget is where the LSL lives, but we actually need it to be set to UDP for the moment for the Unity examples that we've built.
yeah.
cool.
So now the game is on. Wait, let me show.
I can pause it.
Yeah, you got to switch There we go.
So
yeah,
you see
little
what
cat.
Connor is seeing inside
Yeah.
VR. And
Yes.
this game is called Cat Runner. It's basically similar to Temple Run, where you're making a character move either right or left. But in this case, he's not using the controller. He's just using his face muscles, in particular, left and right cheek.
And so you know that I'm not cheating. I'll put the controller down again.
Yeah. So you can see the two little circles by the cat, blue and green, and that gives him an indication of the data coming from each of the two channels. And the goal is to collect as many tokens as he can. Connor's pretty good at this. He plays a lot. So let's see how far you can get. The magnet's pretty cool.
And Ava, maybe you could talk about.
That wasn't me. The rats are pesky.
What were you saying, Joe?
Without pulling up the GUI again, or maybe if it's easy to switch back and forth, but like talking about some of the filtering, like to change how hard you have to do the muscle movement to trigger the threshold, like the different filters and kind of threshold settings that we have built into this.
Cool. I can talk through some of this, and I'll pause.
Actually, can you open the GUI? Yeah, that's nice. I
Yeah,
will.
minimize this for me.
You just have to change which desktop you're looking at.
Yeah, I'm gonna move it to the other desktop. Can you change?
Yeah.
All right. So now,
Well.
can you move us? Yeah. Cool.
It's a little small on our end, so we won't be able to necessarily see the exact things, but if you can just sort of talk through, there are settings for these types of things. We won't be able to read each field.
Yeah. So the first setting is called smooth, and basically what that really is just the window size of data that's being averaged together to create your current value of EMG. And so if you shrink this to a smaller window, the game will, or the EMG trigger will be more responsive because you're looking at a smaller window of time. If you extend this to a larger amount, you'll get a little bit of lag or a little bit of latency, but the system won't be as jittery. And so what I'll show you is if I go down to the minimum, you see how quickly these settings are flickering. So if I activate my left cheek, it activates quickly, but it also drops back down very quickly. Whereas if I go to the other end, and let's say 2 seconds, if I activate the left cheek a bunch of times, it fills up that bar, and then it really slowly unfills that data. It takes 2 seconds to dump the bin, basically. I like to, and you can kind of tweak this actually in real time. I like to keep it at about 1/4 of a second. That usually seems to work the best for me. The UV limit is actually a microvolt limit, which if data comes in above that limit, it gets ignored. And so this is actually really set so that if dropped packets happen, or if you have movement artifacts of the system moving or jumping across the skin, you can essentially set a threshold for ignoring data that's too large, that's outside of the expected window of the microvolt range. So if I drop this down to 100 microvolts, anything above 100 microvolts in value will be excluded from the data set that gets averaged here. The creep is, this one's a little trickier. This system, the way it works is you can see that there's an inner circle and an outer circle, which are defined as the upper and lower limit of your EMG range. And then there's the actual colored circle that sits between those two limits. And what we're doing is we're normalizing the current colored value between the lower limit and the upper limit. And that's what gets represented in this bar graph. So the purple value in here is actually this purple circle and where it sits between the lower threshold and the upper threshold that we're calculating. If we want to create a larger minimum difference between our upper and lower limits, that's what this one is, which is the min delta UV. So you'll notice that if I increase this value, the outer circle and inner circle that we're looking at as our upper and lower limits will have a larger radius difference. So you'll see now, see how the outer circle got farther away from the inner circle. And basically what that did is it just, as these two circles kind of creep towards each other, once they hit 40 UV, they won't creep towards each other anymore. That's the minimum range. And what that does is allow you to kind of prescribe what your expected flex strength is. So if you're flexing really easily and hard and you're generating a lot of microvolts with each flex, you may actually want to increase this value so as to not trip the switch too easily. But if you're having a hard time tripping the switch, you may want to decrease this value to allow your threshold to be triggered more easily. So you'll notice if I go all the way up to 80, I'll flex my right cheek. Okay, that time I actually did fill it all the way up, but I'll flex it a little bit. And you can see that I'm not necessarily filling the bar the whole way. But then if I drop this down to 10, I'm gonna try and flex the same amount. It's much easier to fill the bar now. So if you're having a hard time tripping the switch, just lower that value and maybe decrease the size of this window. So there's a couple variables that you can tweak and mess with here. And what you'll notice is by doing that, if I go back to the game now, those changes are updated live. Like everything that is now getting streamed out of the GUI here is the live metrics, really just the normalized values in these bar graphs. We're streaming out a decimal value between 0 and 1 for each of these channels. And so without further ado, let me just go back in and we'll do this a little bit longer with new settings applied. Now I'm going to get more false positives because the system is more sensitive. So if I'm talking while I do the demo, you're going to end up probably seeing a lot of accidental activations. Just the system is picking up me talking and thinking that it's intentional EMG activation. So if I go back and I come here and I make it a little bit harder, let's put that back to 40, and I come back in, I should now be able to talk pretty reliably without tripping the switch. But that means that my intentional activation, I have to be that much more strong, or the signal has to be that much better. But this is, the implications of this are pretty profound, for individuals with motor disabilities. I think that this has a lot of value that it can already add in a medical context, to individuals who have motor impairment. All right, cool. We don't have to do this all day, but you can see that once you get the hang of it.
Nice.
I tried to get a little bit too tricky there, but it's very reliable once you train on it. So.
And has any of this been classified or like specific to you as a user, or is this just based on how is is there any signal processing involved or machine learning?
There is signal processing, and it's basically what I just showed you, but there's no ML being applied at the moment here. This is, we did do some data collection and we tried to use an ML model to see if it would be better. And it turns out that basic signal processing is actually better than an ML model that's been trained on limited data. So, cool. The best case scenario is probably using an ML model to adapt the signal processing that we've built to just kind of essentially validate or check. And if there are miscues or misfires in the data where we get a false positive, figuring out how to label false positives and use ML to decode false positives and try to predict when a false positive has been activated. That would probably be the best use of ML for this example. Cool.
Okay, so let's show them. I think we can show synesthesia room.
Great.
So we're gonna show you another one of our demos.
I'll stop the data.
Yeah, if you can open the band power. So this one is called synesthesia room, and it's based, this one uses EEG, whereas the previous one was using EMG. And it's basically a room where you're going and there's a glowing sphere. You'll be able to see it in a second. Let me just launch it while I explain.
Cool.
Um,
I don't know if any of you have noticed that I've been wearing the headset for 45 minutes, but I'm not in excruciating pain at the moment. Like I know that I'm wearing the headset, but it's not uncomfortable. It feels like I'm wearing a normal VR headset currently.
So synesthesia room is just loading, and it's a room where you see this glowing sphere that will change color depending on the brain frequencies. So we actually mapped the colors of the sphere to the band power widget. If you can open the GUI.
Yeah, how do I get the thing mounted? Controller bindings?
So you first need to open the desktop.
Yeah.
And now it's the next one. Oh.
We stopped streaming. Oh no, we got to do a hard reset. I think we're actually
Well,
just
let
trying
me
to stop
try.
it and restarting again. Yeah.
Let me just try
You try to
the
disconnect.
GUI first. Oh, stop the stream.
I'm gonna do a hard reset.
I can do it. 1 sec.
We are stressing our computer pretty hard at the moment.
Yeah.
Doing
Streaming
It's getting
VR.
hot.
Couple questions while we're working through it. Well, actually, I'm going to save the question for LSL towards the end so we can show you in the tool itself. Actually, a question from Matthew Boring. Hey, Matthew, how many people have worn a Galea headset, and how consistent is data quality across individuals? So maybe we can talk a little bit about, like how many people we put it on, and if Robert can hear us in the background in the other room, or Connor, you can sort of relay for him. I mean, I'd say we've put it on more than 100 people at this point since we've been developing it, especially more recently now that we're taking it to events. So we're constantly putting it on and off people's heads. There hasn't been anyone that has too big a head to get into it, which has been a big design constraint, actually. For really, really large heads, there's definitely been a point where like usually one of the EEG sensors or one of the FacePad sensors will become like the problem area to deal with. But we've actually accommodated it pretty well, with a lot of different adjustment mechanisms. I don't know if Connor, you want to chime in with some of the points about the mechanical design and things we've implemented over the process of building the alpha units. Oh, I think we might have lost them as panelists now too. But we'll get further question on that when they get back. There was another question in here from Emmy about, can you speak in a general sense the nature of the 250 developers who are receiving the device, sectors, government versus enterprise, individual enthusiasts with money lying around? Do you have what do you imagine be the best possible outcome for the device? Do you have any concerns about adverse effects from misuse? So right now, I mean, this is a great question. The people that have expressed the most interest and where we're seeing, orders for the beta devices coming in, and sort of the most interesting partnerships we've established already have been kind of across OpenBCI's existing kind of audience of neuroscience researchers, psychology, computer science, academic labs and government labs using our tools for science and research. There's also been kind of interest from the game developer angle of this, and people interested in using this to do play testing of VR media and even just regular screen-based media. I don't know if there's going to be, this is not intended to be a consumer device in this form. What we do intend for this, we know it's not a consumer device, but we do think that this is a platform for the companies that are interested in the intersection of physiological sensors and head-mounted displays This is a pretty powerful development kit that'll let you experiment with what sensors might be applicable for your use case and minimize that down into consumer devices. So that's really where we see, the initial groups of users being kind of more on the enterprise in entertainment, VR, also kind of people with using VR for training and using the physiological data that can be collected through Galea to kind of quantify top performers and provide kind of feedback and neurofeedback and biofeedback into those experiences to give people an awareness of, when they're in the zone and performing at top capacity and when they're out of the zone. Just checking in on the others. Okay, I think we're back. I just gotta promote them again. And here they are. Welcome back.
Hi. I think we're stressing the computer a little bit, but we're back in. And the demo's running, so I'm gonna share my screen.
Yeah, and if you can reintroduce, what experience this is and what data it's using from Galea.
Yeah, can you see the screen? Can you see what Conor is seeing?
Yeah, I'm seeing
Okay.
him with the GUI in the VR view and then the demo room behind it.
Okay, let me minimize the Zoom. So yeah, like I was saying earlier, this is experience. Yeah. This experience is called Synesthesia room. And it's basically a room where there's a sphere that glows in different colors. And there's also some music playing. I don't know if you guys are able to hear it through the Zoom, but both the colors of the sphere and the music tones are mapped to the different band powers. So for example, the alpha band power in the widget is green and it's also in synesthesia room. So if the room starts turning green, it's because you're producing more alpha, which means that you're relaxing and feeling more calm.
Can you guys, Eva, can you see what I see, which is the
Yeah.
GUI?
Can you guys see the glowing sphere and the GUI that Conor is holding?
Yes.
Okay. So you can see what he's seeing. He basically sees the room, but also the GUI, so that we can show you how the colors are mapped, and you can see both the raw data and also the game experience.
So right now I'm gonna close my eyes and produce an alpha, and you should see it in the GUI data, and the room should also turn green. Normally I would have the audio in my headphones so that I could be doing audio neurofeedback very effectively. But just so you guys can hear and we can hear you, we're going to keep the audio in the speakers. But normally this experience is very immersive because you have both the audio and the visual immersion in VR. So without further ado, I'm going to try and turn the room green.
And also I want to mention it's using the active EEG channels. So channels 9 through 16. And when we got disconnected, basically what I did is start another UDP stream that uses the band power data and sends it out to Unity. So if you look at the game, the room is pretty green. And you can also see on the GUI that there's an alpha peak because Conor right now has his eyes closed and is relaxing. And we added music so that, for example, if you're closing your eyes, you'll also be able to tell that you're producing alpha just by how the music sounds.
Now open.
So now it's turning a little more bluish.
And I'll close them again.
So blue is mapped to beta, which is more like when you're concentrating or active. And so when he opens his eyes, it tends to go to blue a little bit. And now his eyes are closed, so it's back to strong green. And you can also see the peak in the FFT on the GUI. So the purpose of this room is to provide like a playground based on neurofeedback so that you can train your brain to be able to produce the different frequencies.
Now I'm simulating a theta, which you can do if you get into a nice deep state of meditation, but I'm going to fake it by blinking my eyes at about 5 hertz.
So theta is 4 to 8 hertz, in case you guys can't see it in the GUI.
And now I'll stop.
And now, while he was doing that, you could see that the room was going to yellow, which is the color that we've mapped to that power band. So right now it looks yellow, a little bit green.
Now I'll chill. Back to green.
Yeah. Now back to alpha. Looks green. That's some strong alpha.
And now out. Cool. Should we try and fire up Galea cart?
Yeah, let's do it.
All right. I'm gonna
Thanks.
take the lead.
I think we've actually got a lot of questions to run through. I think
Okay,
it might
let
be
me
good
stop.
to go through a couple of the
Can you hand me the mouse?
most upvoted questions at this point.
Where is the mouse? Oh,
Here, let
here.
me dock it again. Actually, again.
Yeah, it'd probably be good to shut down the VR itself at the moment. Yeah.
Maybe don't. Right.
Docked.
Or I can even just pull up the regular GUI. I think.
Yeah, that would be easier to see if you pull the regular GUI. Yeah. So one of the one common question from Nam from Boston. Can you forward the raw data through LSL? And maybe you guys could talk through the networking widget a bit more, and also how Galea ties in with LSL today.
Yeah. So can you open the? So you can send out the data using LSL. Connor's gonna open networking right now, and if you go to protocol, you can select LSL.
I'll stop the stream real quick first.
Oh yeah. So you get the same as the other protocols. So you have 3 streams, and you can choose which data to send out, and you can specify a name for the stream and a data type, and then whether you want the filters to be on or off.
Great. And then this actually ties in with another question, which was, is it only 3 streams that can be sent anywhere, or is it possible to send all of the data from Galea over these different protocols?
That's a great question. At this point, from the networking widget, we do max out at 3 streams, but we do have, if I'm not mistaken, I use the thumb slider. There is raw time series data. So this would be streaming all 16 channels here in their raw form, straight from the GUI. So you could do time series data, Galea aux, and send both of those out, and you would have all the raw data from here as well as the Galea aux data from here, which would be pretty much all the data. So a lot of the other data types in here are actually kind of pre-filtered. So, EMG is kind of piped through those EMG signal processing features that we have in there. Band power is essentially a distilled FFT. Here we have the FFT, which is more granular information. So yeah, I think, but this is all, stuff that we can change and improve and add. And if there was a specific stream that you wanted access to, either you could come in here and edit it yourself and create that, or you could work with us and we could create a specific output.
What about with the SDK, or kind of skipping the GUI and trying to build from scratch?
So we could talk more to that. Right now the GUI is in some ways kind of an unnecessary middleman between higher level applications and the device data. The GUI uses BrainFlow under the hood to extract the data from the radio. But you could have just, if you wanted to just bring the raw data straight into a different application, you could use BrainFlow to do that and bypass the GUI altogether.
Cool. I mean, also, if the interest is just in recording all the data that's being collected, this whole session would be saved to a text file or a CSV file, which you can then play back later and ingest in other programs.
Yeah, I can actually open an example if you want to see.
Another common question, actually, which we half answered before you guys got dropped last time. How many people have worn a Galea headset? And how consistent is data quality across individuals? What have we done on the mechanical side to kind of account for different head shapes? And maybe Conor, you can talk about what additional improvements we're planning to make between now and beta as well.
Sure. So I think you started to answer this question before we got cut off, but thus far, we have tested the alpha units obviously on everybody at the company, and so we've gotten 15 or so different heads into Galea with the ability to collect good data from everybody. We have taken alpha devices to Augmented World Expo, and then also a press event last week, and we've put the devices on additional people. So there's obviously still room for improvement in terms of trying to get the headset to easily fit all head sizes and head shapes, but we have we've done a lot, and we've also been tackling that problem gradually over the last decade. And as complicated as the electronics and the radio and all that stuff is for dealing with physiological data, I do believe that the hardest challenge is actually the ergonomics. It would be really easy if we were designing a custom headset for everybody and we could 3D scan ahead and then design a headset based on a 3D scan. But when you're designing a headset to be a dynamic system to adapt to every head size and every head shape, it's a very, very challenging task to implement the right number of mechanisms where we still keep the setup time down to a minimum, but also adjust or allow the adjustment mechanisms to exist for different head sizes and shapes. So that's definitely kind of an optimization or a problem that we are still improving the headset for. But I think we've made some really, really good inventions and designs even for the alpha devices, and it should only get better for the beta units.
Cool. How do you anticipate dealing with interference or EMF, RF bias from attachments, the environment, high bandwidth wireless modules or cooling fans that may be in operation around the device, and also the eye tracking itself?
This is a good question, and right now, we've designed Galea, the Galea add-on, to be electrically isolated from the headset itself. So that's part of the reason why we're not pulling any power off of the headset, and that where the Galea system is battery powered and electrically isolated. We haven't had any issues running the Galea system adjacent to the Index or the Varjo headset, and I think. Within Galea itself, we have, especially for all the active electrodes, we have shielded cabling, and we've done a lot in the actual, design of the electronics to minimize environmental noise, but also resonance from the radio and other components on the board that might, induce noise into the signal. But this is obviously, something that will, similar to the ergonomics, continue to improve over time. But I think, as you can see here, even with the alpha devices and while the VR headset is connected to main, we're getting really, really clean data. And just looking at the noise floor, right? The Galea device is mounted onto the VR headset, which is connected to a computer, which is connected to main. And we're still seeing very clean electrical data, even though the system is dry. So we're really pleased with the signal quality.
I want to quickly show the example of the recorded data that we were talking about. So I'm just going to quickly move it to the screen. And this is an example of a file that would get exported. Every time you run a session, the data gets recorded, and then you get this file with different columns that are like the sample index, each channel, so EMG channel 1, 2, 3, 4, then EOG, then EEG, and then timestamps, heart rate, and EDA. So then you can process that data with other applications if you want.
Cool. Another one, if Galea were used to play test VR games, what metrics would be worthwhile or interesting to track as a developer?
This is a big question. So right now we're growing the data science team at OpenBCI, and one of the main goals over the coming year is to build a kind of high level internal state decoder that is generic and can be applied to anybody that puts their head into a Galea system for the first time. So the idea here is that we have a kind of basic suite of high level internal states of mind. So cognitive workload, arousal, stress, fatigue, concentration, these kind of constructs that we typically only understand as qualitative. The idea is that when we roll this out, we have some type of derivative metric generator that is based on scientific data that we collect internally, and maybe studies that we run with partners. But then the idea is that over time we would continue to refine those models to make them better based on donations of data from beta customers and our partners and collaborators. So that is kind of like if you don't want to deal with the squiggly lines dancing around on the screen and decoding your own data, you can work with that, or you will be able to work with that. We also, believe that the heart rate variability, the pupillometry, a lot of the raw data that you can get out of the Galea system, when it's out there in the wild, you're going to be able to use that information in a very valuable way. A big one, the EMG data. I think that there's a lot of excitement and interest around mind-controlled this and mind-controlled that, but I really do think that the future of interaction, or at least new types of interaction, is what we demonstrated earlier, right? Like the left-right, an ability to use muscles on your body as actuators for physical or digital inputs, in ways that really our muscles were not designed or intended for that. But if we're not using them anyway, we might as well figure out how to use them as new types of actuators for computers.
Great. And then, if during, I know we've kept the voice chatting off for the participants, but if you put something into the chat as we're answering questions, we can try and address that as well as a follow-up for your specific questions. Jessica Wilson asked about the sampling rates, and are all feeds locked to a single setting, or can we set variable sampling rates between channels?
That's a good question. Yeah, Eva, do you want to jump on this?
So right now we are using 250 hertz sampling rate. Are you gonna?
I'll just keep it running.
So we're using 250, but we've successfully got 500 hertz working, and we are working to bump it up to 1,000 hertz.
I guess to add to that, that's for all the EXG channels. The Galea aux data has a different sampling rate, and we're actually doing a breaking change to BrainFlow and the stack to subdivide our packets into basically per data type files. So you'll have a PPG data file, which will have its own sample rate, an EDA data file with its own sample rate, and then an EXG file that has higher sampling rates than what's necessary for PPG and EDA.
Yeah, in the current file that I showed you, they're synchronized. So we synchronize them even though the PPG and EDA have lower sampling rates. But like Conor said, in the next version, we're gonna have individual output files so that it's more flexible.
Awesome. I'm just answering a couple others in chat.
I can also launch Galea karting in the meantime, or do we want to do that later?
Let's do it. Let's do it while we're,
We can keep answering. I'm just gonna set it up.
It just kind of shows other examples of how to use the EOG.
Yeah, if you have any other questions.
Did we, did we designate as a medical device or engage with any regulatory systems? What certifications do we expect to get for Galea? Any partnerships with doctors? That's sort of one combo question.
At the moment, no. Though we are very interested in deploying Galea or a derivative of Galea to help people in a clinical or medical context. I think at this point, we're really just focusing on building the hardware and building the building blocks, but definitely open to collaborations and partnerships that can help get Galea, being used meaningfully by people who need it.
Yeah, so it's not it won't, the Galea beta devices will not be, a medical device. They will have, consumer electronic certifications, but that doesn't mean that they can't be used, in contexts where, research context where it's not required, for the medical device certification to be part of it. We do want to be exploring partnerships that are addressing, kind of medical and health related opportunities for this technology. Kind of a general question about the eye tracking. How does the eye tracking work? Where does that come from? And where does that data become accessible?
Let's see.
Joe, do you want to jump on this?
Sure. Yeah, actually, I know this one. The eye tracking itself is the image-based eye tracking, the camera-based eye tracking will be part of the Varjo Aero. It'll be part of the VR headset. So it's not going to be, that data stream will come through the Varjo, or not Varjo, yeah, I'm sorry, the Varjo like SDK and their own software for making that available. It's not going to be part of this, Galea GUI at the moment. They have pretty good, excellent documentation on that. And also we tested out their headsets pretty extensively when we were selecting our headset partner for beta, and we were pretty happy. We were pretty happy about, the performance of their eye tracking and also the range of data that they make available to you in their SDK in their APIs without needing to pay for extra subscriptions or anything like that.
Whilst VR was closed. So let me try again.
Okay. Eva, maybe you can mute while you're troubleshooting.
I think it should be
It didn't crash us then.
on.
Cool.
Let me just.
So what's this one?
The widget.
Let's get the make sure that we're streaming data.
Yeah, I have the stream on.
So we're about to launch Galea Kart, which is our Mario Kart brain activated demo, in a sense, proof of concept.
Yeah. So Galea Karting also uses the data from Conor's cheeks, but instead of being similar to Temple Run where you either move right or left, this one is analog, so the car will steer depending on how much he's flexing his cheek muscle. So this one is a little more difficult to control, but like you can see, he can make the car go in any direction and steer more or less depending on how much you're flexing that particular cheek.
Oh, missed those ones.
Yeah. I think you needed to collect 30, but you only collected 25. I can start it again for you.
Yay!
I
didn't collect enough.
You can
pins
try
to win.
again.
I lost.
So the goal is to connect 30 pins.
All right, let's try that again.
Let me launch it again.
I was moving too fast.
And the same as the other demo, for this one, you can also tweak the EMG widget settings to make it more or less sensitive. Nice. Get the
I don't really
boost.
want the boost. It makes me too fast.
I think the boost more than an advantage is becoming like it makes it harder.
Yeah, turn on the volume a bit.
Nice, I did it.
Nice.
Another good question in the chat is any current plans on implementing like feedback, such as TMS or or other forms of stimulation?
At this point, no. I'm really interested in neuromodulation, but I do believe that we have a really powerful neuromodulation tool, which is the VR headset. I think that the human mind is extremely receptive to light and sound, and I think we're going to make the most out of the neuromodulation that VR, immersive VR, has to offer before integrating any type of electrical neuromodulation.
Cool.
That's not to say that you couldn't do that on your own with a Galea device, though. Cool. How are we doing on
I see a question here about kind of what elements of Galea will be open source, and how much like other designs from OpenBCI. This is a good question. We're basing, like I said, mentioned before, we're using BrainFlow as kind of the core of our SDK. It's an excellent open source project that we've supported and used with our hardware for some time. There's going to be extra features specific to Galea that would be built on top of, but compatible with BrainFlow that may not be fully open source. There's going to definitely be more of a dual licensing model around some of the features for Galea based on the time, resources, and years of R&D on our end that went into it. Unfortunately, there's been, it's somewhat difficult to get credit and also get feedback and get contributions back from major companies that utilize, open source code that we've put into the world. And something that we've learned from our, earlier efforts, where we're going to be setting up more of a dual license strategy, where for academic and non-commercial use, you have more access to source code, but for commercial use, you would not be able to have, and utilize all of the code that goes into Galea in the same way.
Yeah, and to add to that, it'll be different for the hardware. Like, we're obviously still designing the hardware. Like, we have prototypes of the hardware, but when we have a final system and we're starting to ship Galea beta units, then like we've done for all of our other hardware, we're gonna release the Gerber files for the PCBs, because part of this, and OpenBCI's mission is to democratize the technology, and so getting the PCBs out there, we want people to emulate the Galea platform. We want other devices out there in the world that are using the architecture that OpenBCI is designing. And so, we're going to do what we've always done and put a lot of the technology that we build out into the world when we're done building it.
I moved the GUI to the other screen, by the way.
Oh, that's why. Okay,
Yeah.
cool.
I also opened the packet loss widget so that you can see second session that we run, which has been like 30 minutes, is also 0 packets lost.
Great. Wow, we've wasted the time. We're already 80 minutes in, huh?
Are the dry electrodes replaceable? Or talk about the electrodes, cleaning the electrodes when they wear out, and also replacing them.
Yeah. Why don't we, should I take the headset off?
Yeah, maybe stop sharing the screen
Yeah.
and go back to showing the device itself.
You guys are going to see the squid marks on my face, which are going to be, see if you can see them. You can see where all the electrodes were touching a little bit. Got a little bit of sweat in there. Woo, 80 minutes in. That's not bad. That might be a record.
How do you feel in terms of comfort?
I feel pretty good. By the end, I was definitely feeling the headset, but I was not, I had not reached unbearable levels of discomfort or pain. So that's quite encouraging.
Ear clips.
Ear clips coming off. Dun, dun, dun. All right, so you can see in the headset, we've put a lot of effort into designing this in a way that it is modular, and we have things that are replaceable. This gasket in itself can come off, and so that if there's an issue with the face interface, it's pretty easy to swap out the interface for a new one. But even within the face pad itself, we have a electrodes that can click in and click out. And so I just popped an electrode out. So if one of the electrodes starts to wear out, you can remove it and replace it pretty easily. And then similarly, these electrodes are designed, these are the active electrodes that have a PCB in them, but it's quite easy to pop one of these out. I probably shouldn't do this live, but I'm going to try to. Actually, I'm not going to do that. I'm going to leave that in there, but you got to just trust us that those things pop out and then you can pull the polymer off and put a new polymer on. So everything, we've ever since day one, we've tried to, be the Lego of brain computer interfacing. And we're definitely trying to still kind of move forward with that design mentality where ideally, this system is adaptable and changeable and you don't have to redesign the entire system to replace or upgrade an electrode. And so the goal, will be for beta that we have this kind of modular design where if we roll out a new electrode design or a different polymer that maybe works better for certain hair types, you can just easily swap that into the system if it improves the system for your use case.
Let's also show where the PPG and EDA are. I don't know if we showed them earlier, but
Sure.
the PPG sensor is right here. So the middle of the forehead, and then the EDA is plus and minus these two electrodes.
Yep.
One question, will it be possible to sync this with stuff like Oculus models?
Stuff with like what?
Like the Oculus, people want to ask it, what headsets will it be compatible with for the near future?
So in the beginning for the Galea beta, we're going to be shipping the beta devices attached, or rather the Varjo Aero will be attached to the Galea headset. But the way that the Galea headset is going to be designed is, the entire headset will be the Galea headset, and there will be the ability to attach, if you want to, different displays into a piece that we're calling the nest at this point, which essentially is the bridge between the HMD and the rest of the Galea headset. And so in theory, you could attach other displays, though for our beta release, we're going to be doing all of the work to attach Galea to the Varjo Aeros and shipping the devices and the SDK with the Varjo Aero as the main HMD that we're focusing on.
Great. Yeah, I think there's a couple other, some questions about biofeedback and how that would be displayed, but I think we've kind of worked through a lot of the questions that have answers at this point. If there's anything else, you can drop it into the chat. Let me see. There was, one question from Armen. Is there a biofeedback feature, where you can display biological data inside of the VR environment and user can learn to control it? I think this was asked pretty early on in the session, so hopefully that's more clear to everyone after the demos, but the answer is yes, definitely. That's the whole point, is making it possible so that all of the streams of the device, the data streams of the device, can be accessed inside of Unity. Another one was, is this just designed to work with Steam VR? Does Varjo have its own software? Is there any restrictions from Galea on what VR tools can be used for experiences that are compatible with Galea?
I would say that the biggest limitation at this point is that the system is Windows only. And that's mainly because most high-end VR systems are Windows only. And I would say, but beyond that, from a developer perspective, BrainFlow is very open-ended and it's designed to be highly extensible. So it's written in C and C++. So integrating it into a higher level programming language is very easy. And as a result, integrating Galea is just as easy. So, for developers who don't want to work with our GUI and maybe would prefer Unreal Engine for 3D development over Unity, all of that will have an Unreal SDK that kind of demonstrates how to do it. But, it's the low level SDK that we're using, BrainFlow, is really designed to be, it's designed for developers. It's designed to be highly extensible.
Yeah, and the source code is C, C++, but it has wrappers and support for Python, MATLAB. You can integrate it in Unity, etc. So it's very easy to get started with it.
There was a question. It's can you estimate the time delay between, Ryan specifically asked about the EOG data, but I think this can kind of apply to any of the data we're collecting. Like, can you estimate the time delay between, EOG data that Galea collects and the headset display updating? And actually, I think Eva, maybe you could talk about some of the time syncing studies and work that we did last year on this front.
Yeah, so we've actually been running a few tests on calculating like the round trip time, sorry, and to make sure that our timestamps between the device and the PC are correctly synced. And when you record your session using the GUI, it actually exports a different file that has 3 values: the timestamp coming from the device, the PC timestamp, and the round trip time, so that you can check the difference and use this in your calculations.
Do you know anything off the top of your head about kind of the average?
So let me check.
But but what you're saying is that this is something that you can monitor.
Yeah, it's basically something that you can monitor, and we are like making sure that we log this data so that you can take it into account. Off the top of my head right now,
15 to 30 milliseconds.
Yeah, for the current data, it's something like that, but we ran this test quite a while ago, so I would say we probably need to run them again with the Aero once we have the next version of Galea and provide updated data.
Yep. And this is all
Yeah.
subject to change. There's a lot of architecture shifts and things going on at the moment that will hopefully only improve that round trip time.
Cool. Well, I think we're at the end of our time. Thank you, everybody that's actually that's stayed with us through the full presentation. Hope that some of the stuff that you've seen has kind of given you a few ideas about how this technology can be applied. We will be following up with kind of a recording of the session with you all over email. Thanks for those of you that registered with your email. That's the email you'll get it to. If you have kind of more specific questions about Galea that you want to ask, or you want to set up some time to talk with us about something specific that you're working on, the best way to get in touch with us would then be it's galea@openbci.com. And someone, most likely me, will get back to you and answer your questions or set up a time to talk.
Don't be shy. Yeah. It's a fun time to chat with us because we're developing collaborations and partnerships actively.
Yeah.
Thanks, everybody, and
thanks
hope
for
the
coming.
rest of your Wednesday is good.
Thank you, everybody. Take care.
Bye.
Bye.